Our universe is a vast and mysterious place. It's filled with billions of galaxies, each containing billions of stars. But have you ever wondered where it all came from? How did this incredible cosmic dance begin? The answer, according to scientists, is the Big Bang. The Big Bang theory is the prevailing model explaining the origin of our universe. It suggests that the universe as we know it began from an extremely hot and dense state roughly 13.8 billion years ago. This wasn't an explosion in the conventional sense like a bomb going off. Instead, it was the rapid expansion of space itself everywhere at once. To grasp the enormity of the Big Bang, we need to rewind the clock almost 13.8 billion years. Imagine a universe compressed into a point of unimaginable density and temperature. This point, known as a singularity, contained all the matter and energy that would eventually become everything we see around us today. This singularity wasn't just incredibly small, it was also incredibly hot. The temperatures and pressures present in this initial state were beyond anything we can recreate in a laboratory. It's difficult for our human minds to truly comprehend the conditions of this singularity. Then, in an instant, this singularity began to expand. This wasn't an explosion in the traditional sense, with matter bursting outward into empty space. Instead, it was the fabric of space itself stretching and expanding, carrying the incredibly dense matter and energy along with it. This expansion, known as inflation, occurred at a mind-boggling speed. In a fraction of a second, the universe grew from something smaller than an atom to an astronomical size. This rapid expansion was crucial for the formation of the universe as we know it. Imagine a balloon with tiny dots drawn all over it. As you blow air into the balloon, it expands, and the dots move further apart. This is a simplified way to visualize the expansion of the universe. During inflation, the universe expanded much faster than the speed of light. Einstein's theory states nothing can travel through space faster than light, but space itself can expand. This uniformity is observed today in the cosmic microwave background radiation. As the universe expanded, it also cooled down. This cooling was crucial for the formation of the first atoms. In the extremely hot and dense conditions of the very early universe, matter existed as a sort of cosmic soup of elementary particles. These particles, including quarks and electrons, zipped around at incredible speeds, constantly colliding with each other. As the universe cooled, these collisions became less energetic. Around 380,000 years after the Big Bang, the universe had cooled enough for protons and neutrons to combine and form the first atomic nuclei. These nuclei, mostly hydrogen and helium, were still surrounded by a sea of free electrons. It took another 380,000 years for the universe to cool enough for electrons to be captured by these nuclei, forming the first neutral atoms. This event, known as recombination, marked a turning point in the history of the universe. Before recombination, the universe was opaque, like a dense fog, because photons couldn't travel freely without bumping into charged particles. After recombination, the universe became transparent, and light could finally travel freely across vast distances. Section 5, From Soup to Structure, the Birth of Stars. After the formation of atoms, the universe was still a relatively smooth and homogeneous place. However, tiny variations in density, seeded during inflation, began to grow under the influence of gravity. These denser regions attracted more and more matter from their surroundings, becoming even denser. Over millions of years, these clumps of matter grew larger and denser, eventually collapsing under their own gravity. As these collapsing clouds of gas and dust contracted, they heated up. The pressure and temperature at their cores became so intense that nuclear fusion began. Hydrogen atoms were fused together to form helium, releasing enormous amounts of energy in the process. This marked the birth of the first stars. These stars were massive and short-lived, fusing hydrogen at furious rates. They were the furnaces where heavier elements such as carbon, oxygen, and iron were forged. Section 6. Galaxies, islands of stars in the cosmic sea. While stars were forming and evolving, gravity continued to shape the universe on larger scales. The denser regions of the early universe, where stars were forming, attracted each other gravitationally. Over billions of years, these regions coalesced into vast collections of stars, gas, dust, and dark matter, the galaxies we observe today. Galaxies come in a variety of shapes and sizes, from spiral galaxies like our Milky Way to elliptical galaxies and irregular galaxies. Within these galaxies, stars continue to form, live, and die. The death of massive stars and spectacular supernova explosions scattered the elements they had forged into space. These elements would later become incorporated into new generations of stars and planets. Galaxies themselves are not randomly scattered throughout space. They are organized into clusters and superclusters, connected by filaments of dark matter, forming a vast cosmic web that stretches across the observable universe. Section 7. Echoes of the Big Bang Cosmic Microwave Background. If the Big Bang really happened, we should be able to find some evidence of it today. And we do. The cosmic microwave background radiation is the afterglow of the Big Bang. About 380,000 years after the Big Bang, atoms formed and light could travel freely. As the universe expanded, this light stretched out, becoming faint microwave radiation. Today we detect it as faint microwave radiation from all directions in the sky. The expanding universe, a never-ending story. For centuries, astronomers believed the universe was static. In the 1920s, Edwin Hubble discovered galaxies are moving away from us. This implies the universe is expanding, as the Big Bang theory predicts. The expansion of the universe revolutionized our understanding of the cosmos. Current observations suggest the expansion is accelerating. Section 9. Mysteries yet to be solved. While the Big Bang theory is a remarkably successful model, it doesn't explain everything. There are still many mysteries about the universe's origin and evolution that remain unsolved. One of the biggest mysteries is the nature of dark matter and dark energy. These mysterious substances make up the vast majority of the universe's mass and energy, but we don't know what they are made of. Another mystery is the origin of the universe itself. What caused the singularity to exist in the first place? And what triggered the Big Bang? These are questions that physicists are still grappling with. Furthermore, we're still trying to understand the details of inflation, the period of rapid expansion in the very early universe. What caused it? And what are its implications for our understanding of fundamental physics? Despite these remaining mysteries, the Big Bang theory remains our best explanation for the origin and evolution of the universe. It's a testament to the power of science to unravel the secrets of the cosmos. Section 10. Our place in the grand scheme. The Big Bang theory tells a story of cosmic evolution that spans billions of years. It's a story that began with a tiny point of unimaginable density and temperature, and it has led to the vast and complex universe we observe today. In this grand scheme, our planet Earth is just a tiny speck, orbiting an ordinary star in a vast galaxy. But despite our insignificance in the cosmic order, we humans have been able to piece together the story of our universe's origin. Through careful observations, ingenious experiments, and the power of human thought, we've been able to look back billions of years in time and understand the events that led to our existence. The Big Bang theory is a triumph of human curiosity and ingenuity. As we continue to explore the universe and refine our understanding of the Big Bang, we gain a deeper appreciation for our place in the cosmos. We're part of this grand cosmic story, a story that began with the Big Bang and continues to unfold today.